Before defining sine and cosine, we need to remember that the equation of the unit circle is given by x squared plus y squared equal 1. And also, we need to remember that for every angle, let's say 400 degrees, then there is a unique point in the unit circle that goes with that angle. 400 is coterminal with 400 minus 360, which is 40 degrees, and 40 degrees is about, this is the angle of 40 degrees, and then this is the point x and y that goes with 400 degrees. The equation of the unit circle allows us to find points in the unit circle. For example, if we know that x is equal to negative 1/3, then we use the equation and we get negative 1/3 squared plus y squared equal 1. Then y squared is 1 minus 1/9. Remember, negative 1/3 squared is just positive 1/9. We move it to the other side, and then we get that y squared is 8/9, and that means that y is plus or minus a square root of 8 over 9, which is a square root of 8 over 3, and this is just 2 a square root of 2 over 3. 8 is 4 times 2, and the square root of 4 is 2. Then we get this, and then there is a plus or minus here. That means that we have 2 points, and these 2 points are here. This is x equal negative 1/3, and the positive solution, here we have negative 1/3, 2 a square root of 2 over 3, and here we have negative 1/3 and negative 2 a square root of 2 over 3. Then with the equation of the unit circle, we can find points in the unit circle. And we also know that for every angle, it doesn't matter if it is in degrees or radians, we can find a point in the unit circle. Then with this combination, we can define sine and cosine. Let's see that. Essentially, this is what we do. Given an angle, theta, we find the x and y, as I said here, and then we say that the sine of the angle is just the y, and the cosine of the angle is just the x. Easy examples. For example, theta equal 90 degrees. For theta equal 90 degrees, we think about the unit circle. 90 degrees is here, and then that point is the point 0,1. Remember, for every angle, it doesn't matter if it is in degrees or radians, we can find an x and y in the unit circle that goes with that angle. Remember, this is the starting rate, final rate, and we have 0,1. Then that means that sine of 90 degrees is, the y is 1, and cosine of 90 degrees is the x, which is 0. These are some basic examples, and we can use the calculator to find the point in the unit circle. Let's do an example. If we think about just 20 degrees. 20 degrees, this is the unit circle. 20 degrees is something like here. This is the point xy. Without the calculator, or it would be a little challenging to find the x and y, but with the calculator, we know that sine of 20 degrees is equal to 0.3420 approximately. Cosine of 20 degrees is 0.9397 approximately. And that means that this point here is the point x, but x is the cosine, 0.9397 approximately, with 4 decimals, and the sine is 0.3420 420 approximately. Okay, then with the calculator we can find sine and cosine of any angle. And the interpretation for sine and cosine is that for any angle we find the x and y, and once we have the x and y, then we can find sine and cosine, because cosine is the x and y is the y. Those x and y must be in the unit circle. That means that they must satisfy x squared plus y squared equal 1. Notice that here with the definition it's very evident that it doesn't matter what angle we have. We have that cosine squared of theta plus sine squared of theta is equal to 1. The reason is because cosine squared of theta is just x squared and sine squared of theta is just the y squared. A little observation is that we used to denote sine squared of theta. This means sine of theta, everything in parentheses, squared. We use this notation. We put the 2 here after the n so that we don't get confused with sine of theta squared, because this may be thought as sine of the angle theta squared. And then for that reason, instead of writing sine of theta, everything in parentheses squared, we write the 2 next to the n. Okay, this is all for this video about the definition of sine and cosine.